Alright, so today we're going to be talking about parallel lines and proportional parts. So proportions can be used to find lengths of segments determined by parallel lines. The first theorem that we're going to talk about today is the triangle proportionality theorem. This theorem states that if a line is parallel to one side of a triangle and intersects the two other sides in two distinct points, then it separates these sides into segments of proportional length. So if we look at this example here, we have a set of parallel lines, and one of them is located within the larger triangle. So when it is cut up like this, we can say that CB over BA is proportional to CD over DE. So both of those segments are going to be proportional. So let's look at an example here. So it says to find the value of x, for example, 1. So what I'm going to do is I'm going to set x over 1, and I'm going to set that equal to 8 over 2. And the reason I'm setting it like that is because they are proportional to one another. So what I'm going to do next is simply cross multiply. I get 2x equals 8, and then x equals 4. Alright, so moving on to the second example, it says find the values of x. So once again, I'm just going to set up my proportion here. I'm going to do 5 plus x over 3, and I'm going to set that equal to 8 plus x over 4, and I'm going to simply cross multiply. When I do that, I do 4 times 5 plus x, which when you simplify that gives you 20 plus 4x. And on the other side, I'm going to multiply 3 times 8 plus x, which gives me 24 plus 3x. So I'm just going to solve for x now. I'm going to subtract the 3x on both sides. I get x. And then I'm going to subtract the 20 on both sides, and I would end up with 4. All right, looking at the next theorem, the next theorem that we're going to talk about is the converse of the triangle proportionality theorem. This theorem states that if a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional lengths, then the line is parallel to the third side. So it's kind of the opposite of what the triangle proportionality theorem stated. So this time, if you are given, you can find that the corresponding segments are proportional, then you know that that line is going to be parallel to the third side. So let's look at this first example. It says in triangle EFG, EG is 15. I'm going to go ahead and label that. So EG is 15, and then EH is 5. So this portion here is 5, and then LG is twice FL. So LG is 2 times x, whereas FL is x. Or in other words, if FL is x, LG is 2 times that x, since it's twice FL. All right, so with that information, I can now set up my proportion. Well, actually, no, I need to figure out what HG is first before I can do that. So if I wanted to do this, I could just simply subtract 15 minus 5, and over here I would get that HG is 10. So now I can set up my proportion. I can do 5 over 10 equals x over 2x. Now I'm trying to determine whether or not HL is parallel to EF. In order to do that, I'm going to see, does 5 over 10 actually equal x over 2? So what I'm going to do is simplify both sides. So on the first side, I get 1/2, and on the second side, I also get 1/2. So because they are the same, then I would know that, yes, they are proportional, and so therefore HL is parallel to EF. All right, for this next portion, it says in triangle ABC, find x so that DE is parallel to CB. Okay, so it tells us that AC is 30, so this whole thing is 30. It tells us that AE, so this portion is 22. It tells us that AD, so AD, just this portion, is 10. And EB is x plus 4. So to set up my proportion here, I do need to figure out what DC is. I can find that by subtracting 30 minus 10. That gives me 20. So from there, I can set this up. I can say that 10 over 20 is equal to 22 over x plus 4. Okay, so what I'm going to do is cross multiply because we're basically finding x so that they're parallel, right? We're not seeing are they parallel, we're actually trying to find x to make it parallel. So once I set up my proportion, I'm going to solve for x. So I have 10 times x plus 4 is equal to 440. So instead of trying to distribute the 10, I think it's easier to just divide it out on both sides. So when I do that, I get x plus 4 equals 44, and then I'm going to subtract 4 on both sides. I get x equals 40. So when x is 40, then that means if x is 40, that means that the segments are proportional and have proportional lengths. And if that's true, then we know that DE is going to be parallel to CB when x is 40. All right, for this next portion, we're looking at the mid-segment of a triangle. So this is a segment whose endpoints are the midpoints of two sides of a triangle. So we've kind of talked about that in the previous lesson. So a mid-segment of a triangle is always parallel to the third side of the triangle, and the length is half of the length of the third side. All right, so with that, let's try to solve example 5. It says find the values of x and y. I'm going to start off by finding the values of x first. So we know that because the mid-segment of a triangle is always going to be half of the third side, so then I'm going to say that 1/2 of x plus 11 is the same as 4x minus 5, okay? So from there, I'm going to go ahead and solve for x. I'm going to start off by multiplying both sides by 2 to get rid of that 1/2. And so when I do that, I get 11 or x plus 11 on one side, and on the other side I have 8x minus 10. So if I move the 10 over to the other side, I get 21, and if I move the x over to the other side, I get 7x. If I divide 7 on both sides, I get that x equals 3, okay? So now I need to find my y value. So one thing that I know is the mid-segment is always going to go through the midpoint, which means that both sides of that midpoint are going to be congruent. So then I can just say that 4y plus 6 is equal to 2y plus 18. Okay, so from there, I'm going to go ahead and subtract 2y on both sides. So I get 2y equals, and then I'm going to subtract 6 on both sides. So I get 2y is equal to 12. And then when I divide both sides by 2, I get that y equals 6. All right, moving on to the next theorem. The next theorem is the 3 parallel lines theorem. If 3 or more parallel lines intersect 2 transversals, then they cut the transversals proportionally. All right, so what that means, we can say PQ over QR is equal to DE over EF. Now, you could also say PQ over PR, if you wanted to, is equal to DE over DF. You could also use QR over PR equals EF over DF if you wanted to, right? So it doesn't matter which parts you're using as long as they're corresponding. All right, let's do some examples. So on example 6, it says find the value of x and round to the nearest hundredth. So I'm going to do 5 over 7 is equal to the corresponding parts on the other side, which is x over 9. Right? So we have our 3 parallel lines, which is why we know that they are going to be proportional. So I'm just going to go ahead and solve for x. I get 7x equals 45. And then I'm going to divide both sides by 7. And so then I get that x is approximately 6.43. All right, let's look at one that's a little bit harder. So this time we actually have 4 parallel lines, but it doesn't matter because the theorem states that you can have at least 3, right? So if 3 or more parallel lines intersect two transversals. So you can't have more. So all of these parts are going to be proportional on both sides. So it asks us to find both x and y. I'm going to start off by finding x. So I'm going to do x over 3, and the reason I'm using 3 is because that has a complete set, if you will. So 3 and 4 don't have any variables, they're kind of perfect numbers. So I'm going to do x over 3 is equal to x plus 3 over 4. All right, so I'm going to go ahead and cross multiply. When I do that, I get 4x equals 3x plus 9. So I'm going to subtract the 3x on both sides. I get x equals 9. So that's my x value. Time to find my y value. So for my y values, I'm actually going to choose this set, and I'm also going to choose this set, just because I feel like those are the easiest ones to work with. Obviously, you have to use the first set because you're solving for y, but then the second set, it doesn't really matter which one you use, as long as it doesn't have the same variable, or as long as it either has the same variable or just a constant. It can't have a different variable. Now x and x plus 3 do have a different variable, but if you wanted to use that, then you would have to plug in that 9 first so that we can get rid of that variable. Anyways, I'm not going to make it that hard on myself. I'm just going to use parts that are already constants. So I'm going to do y over 3 is equal to 2y minus 5 over 4. I'm going to cross multiply. When I do that, I get 4y equals 6y minus 15. I'm going to subtract the 4y on both sides, so I get 2y equals positive 15. I'm going to divide both sides by 2, and so then I get that y equals 7.5. This next theorem, we have the triangle bisector theorem. This theorem states that if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So if we look at this example, we have AD over DB, right? So AD over DB is equal to CA over BC, all right, or CB, right? So the parts of that triangle are going to be proportional, right? So let's do an example here. So in the diagram, it says that angle QPR is congruent to angle RPS. Use the given side lengths to find the length of RS. So first of all, I want to kind of look at all my parts. So I have RS. I don't have QR, but I do have the entire side length QS, right? If I wanted to find QR, I could simply do 15 minus x, and that would give me my QR, right? I have my PQ, I have my PS, so then I can go on with writing my proportion. So I'm going to do 15 minus x over x, right? So I use the first half of the triangle first. I have to use the first half of the triangle the second time, right? So then that means I have to use 7. That's the one that's corresponding to it, right? So 7 over and then 13, right? So that's like kind of the bottom half because we ended with the bottom half on the first one. So I'm going to then cross multiply and then solve for x. When I do that, I get 195 minus 13x equals 7x. So from there, I'm going to add the 13x on both sides. So I get 20x equals 195. And when I divide both sides by 20, I get that x is equal to 9.75. This next page is just some examples of word problems that have been solved. I'm just going to kind of quickly go over some of these with you. So this first one says, when Stephanie stands 2 feet from a lamppost, her shadow is 3 feet long. If Stephanie is 5 feet tall, how tall is the lamppost, right? So we're going to round to the nearest hundredth. So this right here would be the lamppost. It says that she's standing 2 feet from the lamppost, right? So she's right here, and she is 5 feet. So her shadow, which is right here, right? It's going to be the opposite of the lamp post, right? So her shadow is going to be 3 feet. So the question here is, how tall is the lamp post? So in order to do this, you're going to simply set up a proportion. So we have x over 5, so those are the two heights. So the height of the lamp post over the height of Stephanie. And then I'm going to say is equal to 5, which is the entire length, right? The entire length, because we had the entire first leg, so I have to do the entire second leg, right? So x, the height of the lamp post, is part of the entire triangle, right? So that's part of the larger triangle. So I would have to do the entire leg of the larger triangle, right? So that would be 5. And then over just that smaller triangle, in this case, her shadow, which would be 3. So then from there, you would cross multiply and you'd end up with approximately 8.33 feet. This next example, a tree casts a 36.5 foot long shadow. At the same time, a 28-foot flagpole casts a 14-foot long shadow. Find the height of the tree. Okay, so we have a flagpole that's 28 feet long or high and casts a shadow of 14 feet. So that's shown right here. And then we have a tree. We don't really know what the height of the tree is, but we do know that it casts a shadow of 36.5 feet. Okay, so we are trying to find the foot of a tree. Now, the key word here in this definition, or in this problem, is the at the same time. So we know that it's at the same time, which means that the shadow is going to be at the same angle. All right, so because of that, we can say that these two triangles are proportional, and so with that, I can set up my proportion. So I'm going to do x over 28, so those are my two lengths, so I have my tree and I have my flagpole, and then is equal to then the shadows, so 36.5 over 14, and so when you solve for x, you get x is 73 feet. All right, so for this next one, a mirror is on the ground 8 feet from Ricky and 19 feet from a flagpole. Ricky can see the top of the pole in the mirror. If Ricky is 6 feet tall, how tall is the flagpole? All right, so the mirror is in the middle. On one side, we have Ricky, who's 8 feet from the mirror, and on the other side, we have a flagpole, which is 19 feet from the mirror. So we're told that Ricky is 6 feet tall, and we are trying to find the height of the flagpole. So once again, we are just going to simply set up a proportion here. So we have 6 over x, so those are the two heights, and then is equal to 8 over 19, so that's the distance from the mirror. So then from there, I'm just going to solve for x, and I would get that x is equal to 14.25 feet. On this one, some people get a little bit confused about how to draw this. It actually doesn't matter. Even if you drew it like this, where the mirror is here, and then here's Ricky, and we did the same thing, so this is 8, and then this whole thing is 19. This is x, and then Ricky is 6 feet. If you were to try to solve that, you'll still end up with x equals 14.25. I know that this question was a little bit confusing and didn't specify exactly where he's standing, if he's standing on the opposite side of the mirror or if he's standing on the same side of the mirror. On a test or a quiz, it will be more specific, but for this type of problem, it really doesn't matter how you draw it, you're still going to end up with the same answer.